All right, so this is a week 5 video. This is our last week on truth tables, our last video on truth tables. And we're going to be covering using indirect truth tables, or sometimes they're called partial truth tables, in order to test for validity. I'm going to give 3 examples to show how this technique works. But the basic idea here is that you may have noticed that truth tables can get really large. Here, actually, let me skip into the part of the first examples to show you. Look at this argument here. A and not E, A or B and not D, B implies not C, therefore, A and B implies C or D or E. This is an argument that has 5 separate sentence letters in it. It means that the truth table is going to get really long. It's going to be 32 lines long. We just don't want to have to do this truth table. I mean, look at it. It would just take forever. So the whole point of indirect truth tables or partial truth tables is a way to find a shortcut to not actually have to do a full table in a situation where you've got a million lines that you would have to do. So the most straightforward situation where you can use this shortcut are situations where there's a single line that proves an argument invalid. Basically, you can use these short truth tables, you can use the indirect method whenever you're showing an argument invalid. And so this is, and ideally, if there's only one line that shows it invalid, then the whole process works incredibly smoothly. So again, you imagine this sentence. It's got 5 letters. It's got 32 lines. We don't want to do all of this. But look, there's one line that I've circled. That is the only line out of all of the lines on this truth table where the argument has true premises and a false conclusion. That's the only line we really want. If we can find a way to zoom in on that line and avoid having to write all the other lines, our life would be easier. So if we were to do a full truth table, we would start with the individual sentence letters, the A, B, C, etc. And for each one of those, we would have to do 32 lines because there are 32 possible combinations of truth values for these 5 letters. So we would fill in the columns and we would do the main connective last. And once we have the main connective, then we could find the lines where the premises are true and the conclusion false. But like I said, I want to shortcut this process and just find the one line that happens to exist in this case where the argument that shows the argument invalid. So what I'm going to do is I'm going to do a partial truth table, and I'm going to start this time with the main connectives. So I'm doing things in the reverse order. And rather than doing the full columns, all I'm going to do is I'm going to look for the lines that you want, the lines that I want. In this case, the line where the premises are true and the conclusion false. And we're going to fill things in backwards and do the sentence letter last. And if it works, then, well, we're in luck. We don't have to do the full 32-line truth table. So here's the example where it works. So again, I've written my 3 premises, and then I've got a double bar to separate them from the conclusion. And I write a T under the main connective for each of those premises, under the and, the or, and the conditional. And I write a F under the main connective for the conclusion. And remember, this is just because of the definition of validity. An argument is valid if it is impossible for the premises to be true and the conclusion false. Therefore, if we want to show that an argument is invalid, then we would find a line that shows that it is possible for the premises to be true and the conclusion false, right? So we're going to see if we can create that line. So now take a look at this. The first premise is a conjunction, and it's true. There is only one way for a conjunction to be true, and that's if both sides are true. So this means that we know that A is true and not E is true. Okay, if A is true in one location, we know it has to be true in the other two locations where it appears. So we can start filling in our line more. Okay, now here's another thing. If we've got a conditional that is false, right, which is what we have in the conclusion, we know that the premises have to be, the antecedent has to be true and the conclusion false. Because just as there's only one line where an and statement is true, there's also only one line where a conditional statement is false. So we say if A and B implies C or D or E is false, then the antecedent is true. So that's the antecedent A and B, and the consequent is false. The consequent is C or D or E. So we put a T under the ampersand and an F under the disjunction. And so far this works, right? Because we had already put in a T under the A. But having a true A is compatible with having a true A and B. So that's good. Well, actually, if we look at what's going on in the consequent, the C or D or E, we can see that this actually gives us plenty of truth values really quickly, because there's only one way for a disjunction to be false, and that's if both sides are false. So we've got two disjunctions here, right? So the C is false, the D or E is false. And for D or E to be false, D has to be false and E has to be false. So we fill in all of those. Well, if C, D, and E are false, we can also fill those values in elsewhere. And look, it works out. So we said that E is false in the conclusion, therefore E is false in the first premise. And that fits with what was already going on in the first premise, because we knew that not E was true. So filling that in works. We can also fill in C is false and D is false. Well, we can keep going from there. Actually, we wind up filling everything else in, because we know that if those negations are false, if D and C are false, then their negations have to be true. And that means that the B in the third premise has to be true. And we fill that in elsewhere, and that works. So what we've done here is, by working backwards, we have managed to zoom in exactly on this line. The line where A and B is true and C, D, and E are false. And that's all we wanted. Well, that was a simple example, because that was a case where the truth table worked out. What happens if it doesn't work out? What happens if the argument turns out to be valid? Well, we'll see what happens. We've got A or B. A implies X, B implies Y, therefore X or Y. This is actually a valid argument. But we're going to try to show it's invalid by assuming the premise is true and the conclusion false. But again, based on what I just told you, we should not be able to do this, because in a valid argument, this arrangement of T's and F's is impossible. So let's see what happens if we try to do it. Well, as before, if we've got a false conclusion, if we've got a false disjunction in the conclusion, then we know the two sides of the disjunction are false. That means that X and X is false and Y is false. So we go over here. We move that X and Y over onto the left. The X in the second premise and the Y in the third premise. Now look at the truth table here. If A implies X is true, but X is false, there's only one thing you can do here. That means that the antecedent, the A, has to be false. Because the only way you get a false consequent and a true conditional is when you also have a false antecedent. The same thing happens for the second premise, or the third premise. So we know that A and B both have to be false. What happens if we fill them in over here? We get a contradiction. This doesn't work. We attempted to fill in the full line for this truth table, and instead what we saw was that A and B have to be false, both. But A has to be false and B has to be false. But the disjunction A or B has to be true. And that doesn't work. So the thing that I've circled here is not a proper line on a truth table. We've reached a contradiction. The argument turns out to be valid. And to show that completely, you would actually need to do out the full truth table. So that's the way it's going to work on the test, for instance. You can use indirect truth tables when you are asserting invalidity. But if the argument turns out to be valid, if the argument turns out to be valid, you need to write the full truth table. And I'm just going to arrange things so that you never have a situation where you have to do a 32-line truth table because the argument is valid. All right, there's a third kind of case you have to deal with. This is a situation where there are multiple lines that show the argument invalid. So we can come up with a line where the premises are true and the conclusion false. But there are actually going to be multiple ways we can do it because there are multiple lines that show the argument invalid. So take a look at this. Not A implies B. A implies C or D. Therefore, A and B or C and D, right? We assume the premise is true and the conclusion false. This is just how we start out any indirect truth table. We start from the main connectives and work backwards. Again, we've got a disjunction that is false, so we can make the two sides false. A and B is false, and C and D is false. But now we've reached a kind of dilemma, because look at the sentence A and B. We know that's false. Now look at the truth table for the and. We know that there are actually three separate ways that A and B could be false. A could be false, B could be false, or they both could be false. Let's just fill in all three of those lines, right? So this isn't as neat as the first example where we were just able to zoom in on the exact one line we want, but it's still a little bit better than having to do a 16-line truth table in this case, because we've narrowed it down to 3 lines. Okay, so if A and B are both false, which is what's happening on the third line, we run into a contradiction, because that would mean that not A is true, And if not A is true, then and B is false, then you can't have the first premise be true. We've reached a contradiction there. So we're just going to X out that line. Forget that one. So now we're down to 2 lines, right? Let's try the first one. We take the F, the A, and the B, the F for the A and the T for the B. We move it to the first premise, and we also have an F in the second premise. Having a false A in the second premise, that works. We can actually fill that in any way we want. So let's just pick one. We can just say C and D are false. I'm sorry, C is true and D is false. That's all we need to do. And then that matches what happens in the second half of the conclusion with C and D being false there. And then I forgot to put in the T under the first negation, but that works as well. So the point is that we have managed to find one of the lines where the premises are true and the conclusion false. We could have actually filled this in other ways, but we get to stop here because we just have one complete line, and that was all we needed. Great. So that's what it comes down. So bottom line, we are using truth tables to check for various logical properties: tautology, contingent sentence, contradiction, logical equivalence, consistency, and validity. For almost all of these, we've been doing full truth tables. In this one situation, I'm also having you practice indirect or backwards truth tables, and this is when we are showing arguments to be invalid. Great. And there will be one problem like this on the test.